Assalamu alaikum and a very good morning to all. Today we are going to start with a new topic of the redox reaction. Yesterday we were discussing about the oxides of nitrogen. We discussed some nitrate ions and then we were able to do this question, give the full systematic names of the following. I hope so you have done the homework. Now today we are going to start with a new topic, that is 7.7, from name to formula. Like I will be giving you a name, or in the exam name will be given, and you are going to predict the formula for that compound. Now for example, they have given us a name, that is sodium chlorate 5. In the bracket there is an Roman number 5 written here. So what we have to work out the formula of a compound from this name. So now what is the formula of sodium chlorate 5? This is the question to be answered. Now for this you already know, okay, in this compound you can say what I have a sodium and I have a chlorate. With a chlorate, what is there? There is an oxygen attached. This I told you, okay, whenever what any metal is attached to what any element, when it is attached to oxygen, it is going to be ended with a word ate. So this is your chlorate and this is the sodium. So now the thing is to find, okay, how many oxygen will be here attached with the chlorine, 2, 3 or 4. This is something which I don't know. So for that I have to do some procedure. But I know, okay, the oxidation state of sodium, that is constant, and that is what? That is oxidation number for the sodium is what? That is +1. For oxygen I know that is always what? -2. This is +1. And they have already given you, okay, 5. This 5 is for the chlorine. This 5 oxidation state is for the chlorine. So oxygen is having the oxidation number of -2. And oxidation number of chlorine is what? That is 5. This gives us an idea, okay, for example, this is the formula, this is the chlorate and this is the sodium. So over here sodium is in the +1 and this whole molecule is in the -1. So this means that this will cancel, and as a result this compound will be a neutral one. So what I will do, I will just take this chlorate and I will calculate how many oxygen do I have in this molecule. So what I will do, ClO is equal to what? -1. Now you can see, okay, the chlorate 5 ion has a charge of what? -1. To balance the +1 charge of what? Of sodium, which I did already. Now we can work out the formula of chlorate 5 ion from the oxidation number of oxygen and chlorine. So from the oxygen and chlorine we are going to calculate what? The formula of the chlorate 5. How we're going to do? But I don't know, okay, how many number of oxygen atoms are there. What? I don't know. I don't know. The N is the number of oxygen atom. I don't know how many oxygen are attached to chlorine. This is something which has to be answered. Now what we will do? We will say, we will write like this now. The same I did in the earlier. Now let me change with a pen. ClO. I know what is the charge? -1 as a whole on the whole molecule. Fine. Now this will be equal to, this is an ion compound, so -1. Now chlorine. What is the oxidation number of chlorine? That is already given in the question. That is what? 5. So I'll put over here 5 for the chlorine. Oxygen. Oxygen I know that is what? -2, but I don't know how many atoms of oxygens are present. So I will put what? I'll put N. I'll put N. So how you will do? -2N. And what else I have? I have a 5 over here. I have a 5. Now what I will do? I will transfer this 5 to the other side. So -2N and -1. This +5 will move to this side, so it will become -5. So -1 -5 is -6 -2N. Now divide both on what? -2 on both sides. Now what? This will cancel and you will be just left with N. This negative will cancel. 2 1s are 2, and how many are 2 3's are. So n is equal to what? N is equal to 3. This means the n is equal to what? N is equal to 3. This gives us an idea how many oxygens are attached? 3 oxygen. 3 atoms of oxygens are attached to make this what? Chlorate. This whole will be what? -1, and this will be neutralized with the sodium, and sodium is what? +1. That is equal to what? +1. So this is how we predicted the formula of sodium chlorate 5, sodium and chlorate. Over here now sodium is in the +1, chlorine is in the +5 state, and oxygen for 1 it is -2, and for 3 it will be equal to what? -6. So -6 and +6, that make this molecule sodium chloride as a neutral. This is how we from the name of a compound we can predict its what? Formula. Now Sir Hamza is going to explain this in Uzbek.
Assalomu alaykum hurmatli o'quvchilar. Demak biz bugungi darsimizda moddalarning nomidan ularning kimyoviy formulasini topishni o'rganamiz. Xo'p, savolga e'tibor bergan bo'lsak, demak sodium chlorate 5, ya'ni natriy xlorat 5 ni kimyoviy formulasini keltirib chiqarishimiz kerak. Demak bu yerda biz berilgan nomdan ular moddaning formulasini yozishga harakat qilyapmiz. Demak natriy va xlorat xlor bilan kislorodni birgalikda yoza olyapmiz. Lekin shu bilan birgalikda biz o'sha xloratdagi kislorodlar soni nechtaligini bilmaymiz. U yerda kislorodlar bitta bo'lishi mumkin, ikkita bo'lishi mumkin, uchta bo'lishi mumkin yoki to'rtta bo'lishi mumkin. Ana o'sha kislorodlar sonini nechtaligini bilishimiz uchun demak biz ma'lum kimyoviy hisob-kitoblarni amalga oshirishimiz kerak. Xo'p, bizga nimalar ma'lum bu yerda? Bizga natriy elementini oksidlanish darajasi ma'lum, o'zgarmas +1 ga teng. Kislorod elementining oksidlanish darajasi ma'lum, o'zgarmas -2 ga teng. Va hamda xlor elementining oksidlanish darajasi ma'lum, +5 ga teng. 5 ga tengligini qayerdan bilyapmiz degan savol tug'iladigan bo'lsa, mana bu yerda aytilyapti, xlorat 5 deb. Ana o'sha 5 demak xlorning oksidlanish darajasini bizga hozir bildiryapti. Xo'p, mana shu lar asosida demak biz mana bu yerda birikmamizning formulasini yozib olyapmiz va bu yerda natriyning oksidlanish darajasi +1 ga, xlorat ionining zaryadi esa -1 ga teng ekanligini bilamiz va bu birikmadan xloratni o'zini ajratib olib, uni zaryadi -1 ga tengligini aniqlab olyapmiz. Va undan so'ng biz mana shu joydagi kislorodlar sonini nechta ekanligini bilmaymiz. Shuni aniqlashimiz kerak va biz buni n bilan mana bu yerda belgilab olyapmiz. Shundan so'ng demak biz quyidagi hisob-kitoblarni amalga oshiryapmiz. Demak xlorning oksidlanish darajasi +5 ga teng. Kislorodning oksidlanish kislorodning atomlar soni n ga teng va uni oksidlanish darajasi -2 ga teng. +5 plus n ko'paytirilgan -2 barobar -1 ga teng degan tenglamani tuza olyapmiz. Va bu tenglama demak mana bu joyda ishlanyapti. Ya'ni bu yerda tenglama tuzilgandan keyin mana bu +5 ni tenglamamizni o'ng tomoniga ko'chirib o'tkazyapmiz. O'ng tomoniga ko'chirib o'tkazganda +5 imiz -5 bo'lib o'tadi. Va bizda qolyapti -2n barobar -1 -5. Bu yerda -1 bilan -5 o'zaro qo'shilib -6 ni beradi. Natijada -2n barobar -6 bo'ladi. Bundan n ni hisoblab topadigan bo'lsak, n'imiz 3 ga teng chiqadi. Aniqroq qilib aytadigan bo'lsak, -n barobar -3 bo'ladi. Tenglamani ikkala tomonini ham -1 ga ko'paytirib yuboradigan bo'lsak, n barobar 3 degan javob kelib chiqadi. Demak, bundan xulosa chiqaramiz. O'sha birikmamizning tarkibidagi kislorod atomlari soni 3 ga teng va biz bundan birikmamizning formulasini yozishimiz mumkin. Natriy xlor kislorod 3 degan formula kelib chiqadi.
Okay, thank you, sir. Now we're going to continue with the next topic. I hope so you have understood. Now this is a question. They have given you sodium chlorate 1. You have to give their formulas. From the names you give their formulas. So this is your homework and you're going to submit in the PDF form on the Google class. Now we are going to proceed to the new topic, that is 7.8, balancing chemical equations using oxidation numbers. We have many methodologies. We have ion electron method, we have oxidation number, like chemical equation that can be balanced, like the charges, the atoms, the water molecules. They can be balanced by two methods. We basically have two methods. One is ion electron method, and second is by oxidation number method. So we have basically two types of method for balancing chemical equations. So for this this methodology of by oxidation number, it is used for the nitrate 5 and magnate 7 ions. Whenever these ions are involved in a reaction, they are going to be balanced by this oxidation number method. Now the very first important point, we have some steps which have to be remembered while balancing the chemical equation using the oxidation numbers. The first is you have to identify the oxidation number changes. Like you have to identify where oxidation is taking place. You have to first identify the places where oxidation is happening. Now in the second, you can see over here, step is the oxidation number changes. Then you have to balance that change in the oxidation number. Then you have to balance the charges, and then you have to balance the atoms. Now these are the four main important points while balancing the chemical equation using the oxidation number. Okay, now the very first example they have given us, that is of the copper oxide. Okay, you can see we have taken a copper oxide, fine, and this copper oxide react with ammonia to give you a metallic copper, and nitrogen dioxide gas is released with the water molecule. Now you can see over here what we have to do. This is an unbalanced chemical equation. So what we are going to do, we are going to assign first the oxidation state to all these elements in their compounds. So oxygen here is -2, copper will be +2, hydrogen, for 3 hydrogen, for 1 it is +1, for 3 it will be what, +3. So for nitrogen it will be -3, copper is in the 0, molecular nitrogen is 0, oxygen -2, hydrogen for 1 +1, and for 2 it will be +2. Okay, this is done. Now you have to what first step, identify, you have to find where oxidation number changes are happening. So you can see copper from +2 it is changed to what, to 0. Copper from +2 it is changed to 0. So we have highlighted this with the what, with the red. Now in the nitrogen here, from -3 it changes to what, 0. If we check for the oxygen, -2 here, -2 here. If we check for hydrogen, +1 here, and here also in a +1. So this means that oxygen and hydrogen, their oxidation states are not changed. Just of the copper and nitrogen, the oxidation states are changed. Now this was the first step. This was step 1. Now we have to move to step 2. Now what they're saying, what you have to do, you have to tell us how much oxidation number is changing in those elements. What is the second? Balance the oxidation number. Before balancing, first we have to check how much by amount oxidation number is changed. So you can see over here +2 to 0. So this means this copper has gained 2 electron extra. This is what? This is the gain. And over here from -3 to 0, this means copper has, nitrogen has has lost its electron. As what? It has lost its electron. Okay, this is done now. Okay, now in the third step, now we have to balance the oxidation number changes. How? Now here was I was having two nitrogen. From -3 it changed into 0. This means it has lost 3 electron, and here it was +2 and it has what? Gained the 2 electron. So what I will do, I will multiply this with the 3 and this with the 2. So 3 2s are 6, -6 will come, and here +6 will come. So this means the gain, this was the gain, and here was what? The loss. Now the gain and loss of what? Of the electron, of the charges, this charge the oxidation number changes is by the charges. That is now balanced, you can see in this equation. Now the change in oxidation numbers are -2 for the copper and +2, like for the copper it is what? It is -2, where it is. Okay, you can see over here copper, it was in +2, it has gained 2 electron, so it is what? It is -2, but for the copper, and +3 for the nitrogen. Nitrogen here was in a -3, but it has lost its 2 electron, so this means nitrogen, that is +3, it has lost its 3 electron, and it has gained, copper has gained. Copper has what? Has gained, and nitrogen has what? Nitrogen has lost its electron. Okay, to balance the oxidation number changes, we need to multiply the copper by 3 and nitrogen, the ammonia, by 2. So what we did, we multiply this copper with 3 in the copper oxide, and to balance nitrogen, we multiply 2 in the ammonia case. Now the total oxidation number changes are then balanced, -6 and +6. Note that we do not multiply the nitrogen by 2 because there are already 2 atoms of nitrogen present. So we are not going to multiply 2 with the nitrogen because that is already balanced. Once these ratios have been fixed, you must not change them. Once you have balanced their charges, then you are not going to change them again. Okay, now like you can see with the nitrogen, you don't have to put, just you have to put with this nitrogen, because over here we were having some deficiency. Over here the number of atom, that is constant, that is fine as like in the reactant side, so we do not have to put 2 over here with the nitrogen gas. Okay, now in the fourth step, we are saying we are going to balance the atoms. Okay, now let's have a look. Okay, how many atoms do we have? Copper is 3 here. Copper over here is also 3. 2 nitrogen, yes, I have 2 nitrogen here. Now 3 2s are 6. How many hydrogen I have? Hydrogen, I have 6 hydrogen. Fine, I have 6 hydrogen. How many copper? Copper are 3 in number on both sides. Oxygen, if I want to find for oxygen here I have 3. I have 3 oxygen here, and on this side I have 1 oxygen. So I have to do something for on this side. So I have to multiply this with the 3 because I have to balance this one as well. Nitrogen here I have to, this side also I have 2. Hydrogen, I have 3 2s are 6. Hydrogen are how many? I have 6 hydrogen. Let me erase this another one. Okay, so this gives us an idea. Okay, copper is 3, oxygen is 3 on both the side. Now hydrogen, 3 2s are 6, 3 2s are 6. Now like everything, copper 3, copper 3, copper 3, oxygen 3, here also 3, nitrogen 2, nitrogen 2, 3 2s are 6 hydrogen, and 3 2s are 6 for the hydrogen. Now every atom is balanced. So balance the atoms. There are 6 hydrogen atom in 2 molecules of ammonia on the left, on the reactant side, on the reactant side. Fine, on the reactant side. These are balanced with 6 on the right, as when you will put 3 with the water molecule. This also balances the number of oxygen atom, and this will help you in balancing what? The oxygen atom. The final equation will look like this, like 3 copperic oxide, now 2 molecule of ammonia, 3 atoms of copper, nitrogen gas, and 3 molecules of water molecule. Okay, Now this is another example. Now in this example they have taken magnate. You know, this is from KMNO4. This is from KMNO4. So in KMNO4 this is +1 and this whole is considered as what? -1. Now in this case they are saying K, the ion which is attached to it, to the oxygen. I told you K, whenever any metal is attached to oxygen, it is going to be added with the word ATE. This oxidation state in the bracket, in the numeral, that is for the metal which is attached to this oxygen. So that is the manganese. So manganese over here is in which state? In a +7 state. If I want to calculate this, let's have a look how to do this. KMNO4. Potassium always, it's from first to +1. Manganese, let's suppose I don't know. Oxygen is what? 2, -2. But how many atoms are there? 4. And the molecule as a whole is what? 0. Okay, so -4 2s are 8. -8, and this is what? +1. And here what I have? Manganese is equal to what? 0. Now -8 + 1, that is -7, is equal to what? 0. And manganese will be here. Now manganese and 7 will move to the other side. So now you can see manganese in which state? In the 7th state. Okay, now we can do one another thing. Let me erase all this. Okay, taking a lot of time. Okay, now you can see here, just to give you an idea, I told you okay, potassium +1 and this whole is -1. Let's have this is -1. So the charge on the compound and that is equal to what? -1. I know for the oxygen that is how much? That is -2. But for the 4 atoms that will be what? -8. And manganese I don't know, is equal to what? -1. Now manganese and -8 will move to the other side, -1 and +8. +8 -1 gives you what? 7. So manganese here is in which state? So you can calculate from the compound ion, or you can calculate from the whole compound. So now first we have to write the unbalanced equation, in which we have taken a potassium permanganate, the manganate ion. It reacted with the iron and acidic media is provided to this reaction. As a result, it changes into any manganese sulfate salt, and it is changed into ferric form, and water molecule is released out. Now what you have to do first, you have to write the oxidation states. Oxygen for 1 -2, for the 4 it is -8. Manganese here will be in the +1 because the charge is what? It is -1. Iron is in +2, water hydrogen is +1. Manganese here is in the +2, iron here is in +3. Oxygen -2, for 1 hydrogen +1, and for 2 it will be +2. Now let's have, this is the first step where we find the unbalanced its equation, and we identify the change in the oxidation number. So what we found, the manganese from +7 it is changed into +2, it is changed into +2, and iron from +2 it is changed into +3. Keep this thing in mind, girls and boys, students. This topic is a bit it's very interesting, but a bit you can say you won't be able to understand in the first turn. So kindly listen it very attentively. It is very easy and very interesting basically. Okay, now so there is a change in the oxidation number of the manganese from +7 to +2. This gives you an idea. Okay, there is what? There is a gain of how many? Of 5 electron. And from here, from +2 to +3, there is what? There is a loss of how many? Of 1 electron. 1 electron is what? That is loss from the iron. Okay, now the second step is reduce oxidation number changes. So what has happened? Iron from +2 changed to +3. So oxidation number change, +1 is lost. What has happened? Lost. Now manganese from +7 to +2. So what has happened? -5. There is what? -5 gives you an idea about the gain of the electron. Now in the step 3, balance the oxidation number changes. Now you can see manganese is -5, like it has gained 5 electron extra, and iron, it has lost its 1 electron. So what you will do over here, I think okay, over here you can see there is what, 1 electron loss plus 1 electron. So what you will do, you will multiply this with what, with 5. You will multiply this with 5. So you will get how many? You will get 5 plus 5. You will get 5. I think the screenshot is not taken properly. So okay, here there was a gain of what, of the -5, and here was what, 1 electron loss. This one you can see. So what I have to do when I want to balance the oxidation number changes, so I have to multiply this manganese ion with the what, with the 1, and the iron I have to multiply with the 5. So as a result, -5 and +5, the gain and loss of the electron, the charges, the loss and gain charges, that is going to be now same. Now you can see over here, this is now the complete equation in which the manganate react with the antiferrous salt in the acidic media. It gives you a manganese sulfate salt, and ferric chloride is produced, and water is released out. Now what we have to do, we have to balance the charges. So how we're going to do, if you talk about this is what, this is the reactant side. So on this we have what, the charge -1, and this is +2, and this is +1. So how you will do, this is -1, this is how much, +2, but +2 you have to do, you have to multiply with what, with the 5. So 5 2s are 10. How much? It's 5 2s are 10, and here what I have, -1. So +10 and -1, that gives you what, that gives you 9, but the sign will be what, plus. Now manganese, the charge is what, for the manganese that is -1, and for the iron the charge is what, the charge is 2, but how many iron I have? I have a 5, so I have to multiply that charge with the 5. 5 2s are 10. So 10 minus this 1, that will give you +9. Now in case of the product, now we're going to talk about the product. So in product, the manganese is in which, +2, and iron is what, in a 3, but how many iron? I have a 5. 5 3s are 15, 15 and 16 17, it has no charge. So the total charge on this side, on the product side, it is what, +17. Now on this side it was what, +9, and to this side it was +17. This gives you an idea, okay, the reactant side is deficient by how much? 9 10 11 12 13 14 15 16 17. Yeah, this means okay, I need 8 atoms to this side to balance it. So what I will do, I will put 8 over here. Now you can do -1, this is 10, this is 10, and this will be what, +8. This will be equal to what, +8. So 10 minus 1, this is +9. +9 and +8 will be equal to what? It will be equal to 17. And to this side it already balanced. So to balance the charges, we need what? 8 hydrogen ions on the left side, on the reactant side. This is your left side and this is your right side. Now you can see over here what we did. This is manganese -1. This is -1. This is +10. This will be +8. This is +2. This is +3, but it will make +15, and +2 will give rise to what? 17. So here also 17, and to this side, on the left side 17, and on the right side 17 to this side and 17 on this side. Okay, balance the hydrogen atom. Now what we are going to do, we have to balance the atoms. Manganese over here 1, and product side 1, so that is 1. Now oxygen, we have to balance oxygen. Now oxygen 4 on this side, and on this side I just have 1. So to balance oxygen I have to put 4 here. So now oxygens are also balanced 4. Now iron is how much? Iron to this side 5 and this side also 5. So both are balanced. Now hydrogen. Now let's check hydrogen. Hydrogen to this side 8. So to balance 4 2s are 8. So if we put 4 here, so oxygen will also be balanced and hydrogen will be also balanced. So this is how balance the hydrogen atoms in a water molecule by putting what? By putting a 4 with this one and 8 will be with this hydrogen ions. So this is how we balance this equation KMnO4 which reacted with a ferrous sulfate salt in the acidic media to produce manganese sulfate. It will give you manganese sulfate and it will give you iron sulfate and a water molecule will be released out. Let me write the complete equation for you. Okay, this is like this: manganese KMnO4 plus what? FeSO4. Okay, and this ends with what? This ends with acidic media. You have to provide what? Acidic media to this reaction. Okay, now these are some questions in which you have to balance them by using the oxidation number method. Okay, we just have these three questions and you're going to do it as your homework. Now Sir Hamza is going to explain you same in the Uzbek.
Xo'p, demak biz sizlar bilan oksidlanish qaytarish reaksiyalarini tenglashtirish usullari haqida gaplashdik ingliz tilida. Demak, endi o'zbek tilida shu jarayonni qisqacha tushuntirib beraman. Xo'p, oksidlanish qaytarish reaksiyalarini tenglashtirish. Xo'p, bizga quyidagi misol berilyapti. Mis ikki oksidiga ammiak ta'sir ettirib, reaksiya natijasida mis, azot hamda suv moddalarini hosil qilyapmiz. Bu yerda biz dastlab bilishimiz kerak bo'lgan ma'lumot qaysi elementlarning oksidlanish darajasi o'zgarganligini bilishimiz kerak. Bu yerda qizil rang bilan qaysi elementlarning oksidlanish darajalari o'zgarganligi ko'rsatilyapti. Shu bilan birgalikda har bir elementning oksidlanish darajasi ham aniqlanyapti. Demak, mis oksidida kislorodning oksidlanish darajasi -2, misniki +2. Ammiakda vodorod +1, azot -3. Mis oddiy modda bo'lganligi uchun, azot oddiy modda bo'lganligi uchun ularning oksidlanish darajasi 0 ga teng. Suvda esa vodorodning oksidlanish darajasi +1, kislorodning oksidlanish darajasi -2. Demak, e'tibor berib qaranglar. Bu yerda mana mis elementining oksidlanish darajasi +2 dan 0 ga, azot elementining oksidlanish darajasi -3 dan 0 ga o'zgarganligini ko'rishimiz mumkin. Kislorod elementi oksidlanish darajasi -2, bu chap tomonda, o'ng tomonda ham -2. Vodorodlarniki +1, ikkala tomonda ham. Demak, ularning oksidlanish darajalari o'zgarmagan. Xo'p, bu demak birinchi bosqichida qaysi elementlarning oksidlanish darajalari o'zgarganligini aniqlab olish bosqichi edi. Endi ikkinchi bosqichga o'tamiz. Xo'p, ikkinchi bosqichda elementlarning oksidlanish darajalari necha birlikka o'zgarganligini aniqlashimiz kerak. Bu qanday aniqlanadi? Demak, reaksiyaga e'tibor beradigan bo'lsak, mana misning oksidlanish darajasi +2 dan 0 ga o'zgaryapti. Demak, bu yerda misning oksidlanish darajasi 2 birlikka o'zgaryapti. 2 elektron yo'qotish hisobiga. Azotning oksidlanish darajasi esa -3 dan 0 ga o'zgaryapti. Demak, bu yerda u 3 ta elektron olishi hisobiga, ya'ni 3 birlikka o'zgarayotganligini aytib o'tishimiz kerak. Xo'p, keyingi bosqichda ana endi o'sha olgan va bergan elektronlar miqdorini tenglashtirishimiz kerak, ya'ni balans holatga keltirishimiz kerak. Buning uchun biz o'sha sonlarni shunday songa ko'paytirishimiz kerakki, natijada ularni yig'indisi o'zaro teng bo'lishi kerak. Eng oson, qulay usuli demak qarama-qarshi sonlarga ko'paytirish kerak bo'ladi. Ya'ni mana bu joyda misni oksidlanish darajasini 3 ga, azotning oksidlanish darajasini 2 ga ko'paytiryapmiz. Ya'ni bu qayerdan kelyapti? Azot mana bu joyda 3 ta elektron olganda, mis esa 2 ta elektron berganda, shuning uchun demak mana bu 3 ni mana bu 2 ga va bu 2 ni bu 3 ga ko'paytirish orqali ularni demak balans holatga keltira olyapmiz. Ikkalasiniki ham -6 ga teng bo'ldi. Xo'p, keyingi bosqichda demak bu yerda aytilyaptiki, xo'sh, ikkita azot elementi borligini hisobga olishimiz kerak va shunga asoslangan holatda demak bu sonlarni 2 ga qisqartirib, undan keyin shu sonlarni koeffitsient sifatida foydalanishimiz kerak bo'lar ekan. Ya'ni demak azot olgan elektronlar soni 3 ni misni oldiga, mis bergan elektronlar soni 2 ni azotni oldiga mana bu joyga qo'yapmiz. Undan so'ng mislarni tenglashtirish uchun mana bu joyga 3 qo'ydik. Azotlarni tenglashtirish uchun mana bu joyda o'zida 1 qolyapti. Sababi mana indeksdagi 2 azotning 2 ta ekanligini bizga bildiradi. Xo'sh, endi kislorodlar sonini tenglashtirishimiz uchun demak 2 kere 3 6, demak suvni oldiga 3 qo'ysak azot vodorodlarimiz teng bo'ladi. Shu bilan birgalikda kislorodlar soni ham demak 3 tadan bo'lib tenglashadi. Shu bilan demak kimyoviy reaksiyamiz tenglashdi. Endi keyingi jarayonga reaksiyaga o'tamiz. Bu yerda permanganat 7 ioni temir 2 ioni bilan kislotali sharoitda reaksiyaga kirishib, marganat 2 ioni va temir 3 ioni hamda suv hosil qilgan reaksiyani tenglashtirish so'ralyapti. Demak, reaksiya tenglamasini yozib olyapmiz. Mana manganat 7 ioni, temir 2 ioni va vodorod ioni uchalasi reaksiyaga kirishyapti. Bu yoqda marganat 2 ioni, temir 3 ioni hamda suv moddasi hosil bo'lyapti. Xo'p, undan keyin reaksiyani yozib olganimizdan keyin biz o'sha elementlarni yana oksidlanish darajalari qanday o'zgarganligini aniqlab olishimiz kerak. Permanganat ionidagi marganatning oksidlanish darajasi demak mana bu joyda sizlarga tushuntirib o'tildi. Kaliy permanganat misolida kaliy permanganatdan permanganat ionini ajratib oldik va uni demak tarkibida 4 ta kislorod bor. Kislorodlarning oksidlanish darajasi -2, -2 ni 4 ga ko'paytirdik va u manganat ionining zaryadi -1 ga teng. Va buni hisob-kitob qilganimizda marganatning oksidlanish darajasi 7 ga teng ekanligi kelib chiqdi va mana 7 ni qo'ydik. Undan keyin temir oddiy modda, zaryadi bilan oksidlanish darajasi teng. Vodorodda ham xuddi shunday, marganat 2 ioni va temir 3 ionida ham shunga teng. Ya'ni oddiy ionlarda oksidlanish darajasi bilan zaryadi o'zaro teng bo'ladi. Xo'sh. Ana endi keyingi e'tibor berishimiz kerak bo'lgan narsa marganatning oksidlanish darajasi necha birlikka o'zgarayotganligiga e'tibor qaratamiz. +7 dan +2 ga o'tyapti. Demak 5 birlikka o'zgaryapti. Ya'ni 5 ta elektron olyapti. Temir esa 2 birlikka o'zgaryapti. +2 dan +3 ga bitta elektron berish hisobiga. Xo'sh, ana endi keyingi ishimiz demak balans holatga keltirib olishimiz kerak. Demak 5 bilan 1 ni bu holatda demak 1 ni 5 ga ko'paytirib yoki bo'lmasa 5 ni 1 ga ko'paytirish orqali bu jarayon amalga oshiriladi va undan keyin shu 5 va 1 sonlari koeffitsient sifatida ishlatilishi boshlanadi. Demak, marganat bergan 5 ta elektronni temirni oldiga, temir bergan bitta elektronni esa marganatlarning oldiga qo'yamiz. Bir koeffitsiyentlar yozilmaydi. Xo'sh. Undan keyin biz reaksiyaning o'ng va chap tomonidagi ionlar zaryadlarini o'zaro tenglab olishimiz kerak. Xo'p. Buning uchun demak dastlab o'ng tomondagi zaryadlar hisobladik. Ya'ni bu yerda +2, 5 kere 3 15 qo'shsak 17 bo'ladi. Suv neytral modda, uni hisobga olmaymiz. Demak, endi chap tomondagini hisoblasak -1, 5 kere 2 10, bundan 9 chiqadi. Demak, 17 bo'lish uchun demak vodorodning oldiga 8 koeffitsient qo'ydik va shuning natijasida 17 balansni berdi. Xo'sh. Undan keyingi bosqichda shu demak mana bu joyda shu jarayonlar tushuntirildi. Xo'sh, undan keyingi bosqichda demak atomlar sonini o'zaro tenglashtirishimiz kerak bo'lyapti. Marganitslar chap tomonda bitta, o'ng tomonda ham bitta, temirlar chap tomonda 5 ta, o'ng tomonda ham 5 ta, vodorodlar chap tomonda 8 ta, o'ng tomonda demak mana bu joyda hech narsa yo'q deb tasavvur qilsak 2 ta. Demak 8 ta bo'lish uchun bu yerga suvning oldiga 4 koeffitsient qo'yamiz. Natijada vodorodlar 8 ta bo'ladi. Undan keyin kislorodlarning soniga e'tibor beramiz. Kislorodimiz chap tomonda 4 ta, o'ng tomonda ham 4 ta. Va shu yo'l bilan demak jarayonni tenglashtirib oldik. Endi sizlarga bu yerda savollar berilyapti. Uchta oksidlanish qaytarish reaksiyasi va mana shu uchta oksidlanish qaytarish reaksiyasini yuqoridagi usullar yordamida tenglashtirib chiqishlaring kerak bo'ladi va javoblarni bizga yuborishlaring zarur. Finished.